Welcome to the Constraint Craft, where we explore how artificial limits force innovative shortcuts and breed invention through necessity. Imagine a grid representing the space of all possible solutions. Constraints are the boundaries that paradoxically open doors to creativity. Let's start with a fundamental question. Why do limitations spark creativity instead of killing it? Here's a question. If you had unlimited time, money, and materials, would you create better solutions? The answer is surprising. Research shows that too many options actually cause decision paralysis and reduce creative output. We can model this mathematically. Creativity equals innovation divided by available options to the power of 0.3. More options slightly decrease creative efficiency. This graph shows how creative output actually peaks with moderate resources, not unlimited ones. The sweet spot is around limited, but sufficient resources. Let's explore the first type of constraint, time limits and how they force efficiency. Parkinson's law states that work expands to fill the time available for its completion. Give yourself a month, and the task takes a month. The actual time used equals 95% of the given time, regardless of task complexity. This is why deadlines work. Here's a visual representation. If given 10 hours for a 2-hour task, we unconsciously expand the work to fill those 10 hours with unnecessary complexity. Real-world example. Twitter's original 140-character limit forced users to craft concise, impactful messages, creating a new form of communication. Now let's examine material constraints and how scarcity breeds invention. Consider Apollo 13. Engineers had to build a carbon dioxide filter using only materials available on the spacecraft. This constraint forced pure innovation. They had only these few mismatched parts to work with. The severe limitation forced creative combinations no engineer would try with full resources. The innovation index equals problem urgency divided by available resources. Higher urgency and fewer resources create maximum innovation pressure. Why does scarcity work better than abundance for driving innovation? Because scarcity forces us to focus only on essential features, eliminating nice-to-have additions that dilute impact. Let's explore linguistic constraints and how word limits enhance communication. Hemingway once wrote a complete story in just 6 words, "For sale baby shoes never worn." The constraint created devastating emotional impact. Impact equals emotional content divided by word count. Fewer words with same emotion creates exponentially more impact per word. Compare these rectangles representing word count. The same emotional content compressed into fewer words creates much higher information density and impact. Now let's dive into the mathematical principles underlying constraint-driven creativity. This is the Boltzmann entropy formula. S equals K times the natural log of W, where W represents possible states. W represents the number of possible solutions or approaches available to solve a problem. By reducing W through adding constraints, we reduce entropy, or chaos, making it easier to find optimal solutions. The search space grows as n to the power m, where n is options per decision and m is number of decisions. Constraints reduce the search space from all these dots to just a narrow path, making the optimal solution much easier to find. Numerical example. With 10 options and 5 decisions, the search space explodes to 10 to the 5th power, or 100,000 possibilities. But constraining to just 3 options per decision reduces the space to only 243 possibilities. That's 400 times smaller. Let's examine concrete real-world applications of constraint-driven innovation. Instagram originally was a complex check-in app called Bourbon. The founders constrained it to photos only, and it became a billion-dollar success. This shows the transformation from many features to one core constraint. The single focus created clarity and explosive growth. Haiku poetry uses a strict 5-7, 5-syllable constraint. This limitation forces poets to distill profound meaning into minimal words. IKEA faced shipping cost constraints, so they invented flat-pack furniture. The constraint revolutionized an entire industry. Constraints work through a psychological phenomenon called the focusing effect. Attention equals mental resources divided by number of options. Fewer options means more attention per option. Without constraints, Attention scatters in all directions, like these arrows, diluting focus across too many possibilities. With constraints, attention focuses on fewer, stronger directions. Each arrow represents much more mental energy and deeper exploration. This raises an important question. How tight should constraints be for optimal creativity? The answer is they should be tight enough to force creative thinking, but loose enough that solutions remain possible. It's a delicate balance. The relationship between constraints and creativity follows an inverted U-curve. This curve shows that too few constraints lead to paralysis from infinite options, while too many constraints make solutions impossible. Peak creativity occurs at moderate constraint levels. Mathematically, creativity as a function of constraint level follows this parabola equation, with maximum creativity at x0, the optimal constraint level. Now let's discuss practical strategies for implementing productive constraints. Time boxing means allocating fixed time periods for tasks. For example, limit brainstorming to exactly 30 minutes. Feature limiting means starting with a minimum viable product. Ship with only core features, not every possible bell and whistle. Resource budgeting means setting artificial material or cost limits, even when more resources are available. These three pillars represent the main types of constraints you can implement: time constraints, feature constraints, and budget constraints. The 80-20 rule applies here. 20% of well-chosen constraints drive 80% of innovative outcomes. There's a neurological basis for why constraints enhance creativity. Neuroscience shows that constraints activate the brain's default mode network, which is responsible for creative insight and problem solving. Neural efficiency equals task focus divided by cognitive load. Constraints increase focus while reducing decision-making load. This represents simplified brain network connectivity. Constraints actually enhance certain neural pathways while pruning less relevant ones. By reducing options, constraints dramatically reduce decision fatigue and analysis paralysis, preserving mental energy for actual creative work. Let's examine some powerful historical examples of constraint-driven innovation. The Beatles often used the 12-bar blues constraint as a framework, which paradoxically helped them create revolutionary new sounds. When Twitter doubled their character limit from 140 to 280, user engagement actually dropped 20%. The constraint was valuable. Doubling the character limit paradoxically reduced engagement. The original constraint created better content and user behavior. SpaceX faced severe budget constraints compared to NASA. This forced them to innovate reusable rockets, revolutionizing space travel economics. Let's synthesize everything into a comprehensive constraint equation framework. Innovation equals constraints times urgency divided by resources. This captures the core relationship. I represents innovation output, the quality and novelty of solutions produced. C represents constraint tightness on a scale from 0 to 1, where 0.5 is often optimal. U represents problem urgency on a scale from 1 to 10, with higher urgency driving more innovation. R represents available resources normalized to a standard scale. Fewer resources in denominator means higher innovation. As constraints increase and resources decrease, innovation output typically rises until reaching optimal levels, then may decline if constraints become too tight. Cognitive load theory explains why our brains perform better under constraints. Working memory can handle approximately 7 plus or minus 2 items simultaneously. This is a fundamental cognitive limit. Constraints reduce the items in working memory to manageable levels, preventing cognitive overload and improving decision quality. The top row shows cognitive overload with too many options. The bottom row shows optimal load with constraints reducing choices to manageable levels. Decision quality is a function of 1 over cognitive load. Lower load through constraints means higher quality decisions. What is the minimum viable constraint needed to spark innovation? Start with one well-chosen constraint, not multiple simultaneous constraints. Layer additional constraints gradually. The initial constraint should target the single biggest source of complexity or decision paralysis in your problem space. Constraint effectiveness equals impact times simplicity. The best constraints are both impactful and simple to understand. This shows how one central constraint creates focus among many possibilities. The single boundary is more effective than multiple overlapping constraints. Once you master single constraints, you can strategically stack multiple constraints. Layer 1. Apply a time constraint to force action and overcome procrastination. Layer 2. Add a feature constraint to maintain focus on core value propositions. Layer 3. Introduce a resource constraint to drive efficiency and creative problem solving. This pyramid shows optimal constraint stacking. Start broad with time, narrow with features, and finally tighten with resources for maximum creative pressure. Total impact equals first constraint plus 0.7 times second constraint plus 0.5 times third constraint. Each additional constraint has diminishing returns. Let's conclude with a comprehensive summary of constraint-driven innovation principles. First principle. Constraints actually liberate creativity by dramatically reducing decision paralysis and focusing mental energy. Second principle. Optimal constraints are tight enough to force innovation but achievable enough that solutions remain possible. Third principle. Scarcity breeds innovation through both necessity pressure and focused attention on essential features. Fourth principle. Innovation equals constraints times urgency divided by resources. This captures the mathematical relationship. This final diagram represents the complete system. Constraints form the boundary that focuses creative energy into powerful, innovative solutions at the center. The key takeaway: apply constraints deliberately and strategically to unlock your full creative potential. Limitations are not obstacles, but catalysts for innovation.